Hey coders, welcome back. Let's try to solve one more assessment today. And this is going to be, I think, 21 or 22. I forget actually. So yeah, let's try to go one of the assessment again. And let's try to go on this phone interview maybe. Or maybe online assessment. Uh, Okay, let's go to this online assessment. I think last time I did this phone interview one. And yeah, so there will be two questions. We have like 1 hour to complete and all. So it's basically for simulating, right? What we say, how you can solve the problems, like whenever you are giving OA or in the interviews, right? So here we have like two questions. Let's see. So the first question says like, integer x is a good if after rotating each digit individually by 180 degree, we get a valid number that is different from x, and each digit must be rotated. We cannot choose to leave it alone. A number is a valid if each digit remains a digit after rotation. For example, 0, 1, 8 rotate to themselves. 2 and 5 rotate each other. In this case, they are rotated in a different direction. In other words, 2 or 5 gets mirrored. What exactly it is saying? 6 and 9 rotate to each other. The rest of the numbers do not rotate to any other number and becomes invalid. Given an integer n, return the number of good integer in the range of 1 to n. So n is like 10 to the power 4. Okay. What is this 180-degree rotation? So if we rotate 0, it says like 0, 1 and 8 rotate to themselves. That's fine. And 2 and 5 rotate to each other. In this case, they are rotated in a different direction. In other words, 2 and 5, 2 or 5 gets mirrored. 6 and 9 rotate to each other. So what is left now? 0, 1, we have 2 left, 2, 3, 4, 7, and it says like return the number of good integer in the range of 1 to n. So these are the four good numbers in the range of 1 to 10 is 2, 5, 6, 9. So 2 is there, 5 is there, 6 is there, 9 is there. Um, 1 is not a good integer since they remain unchanged after rotating. Oh my god, what is it? I mean, okay. Uh, After rotating each digit individually by 180 degree, we get a valid number that is different from x. Each digit must be rotated. We cannot choose to leave it alone. A number is a valid if each digit remains a digit after rotation. For example, 0, 1, 8 rotate to themselves. Okay. 2, 5 are basically gets mirrored. So 2 become 5, 5 become 2. 6 and 9, that's fine too, because 6 become 9, rotate to each other. And this guy they rotate in a different direction. In other words, 2 or 5 gets mirrored. Okay. Um, rest of the numbers do not rotate. Any other number become invalid. Okay, I mean just we iterate over each of the elements. So for example, here it is 10. So we have to check numbers from 1 to 10, including, right? So 1 and 10 will be included. And for each of these numbers, like 1, 2, 3, 4, 5, 6, 7, we have to reverse it. Maybe some mirroring is happening, right? So 180-degree rotation. And we still need to check whether after doing this 180-degree rotation, whether that digit is different from X or not. And so let me, I'm not sure. Maybe I can show you what I'm currently thinking about this one, and maybe we will be figuring out. It's not tough, I mean, that's for sure. It's just weird looking question. So now here it says n is equals to 10, means that we have to check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Now 1 is not a good number because 180-degree reverse of 1 is still a 1, and we have to make sure whenever we are doing this 180-degree rotation, that number should be different from the previous number. So 1 changed to 1 and it is equal, so that's why it's not a good number, right? Now 2 gets mirrors to 5, so that's fine. 2 is good. 3, now if you see here, 3 is already invalid. So if you see in this example here, this is, so rest of the numbers are invalid. So 3 is in the rest of the numbers, so that's why it's invalid. 4 is also invalid. 5 is good. 6, yeah, here, right? 6 and 9, that's good. 7 is invalid. 8 is invalid. Why 8 is invalid? Yes, 8 is also, no, 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 here. Okay. I think I understood the question, but it is so boring. I have to. Okay, let me show you. Let me maybe explain using code maybe, and then it will make more sense. So, let's write a get method. So if a equals to 0, or a equals to 1, or a a equals to 8, so I'm taking this condition. So is gonna be reverse rotate to themselves. So I'm just gonna return a maybe, or maybe I can write a switch case here. No, that's fine. And if a equals to 2, or a equals to 5, no, 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 no. If a equals to 2, it is like it gets mirrored, right? They are rotated in different direction, so they will become mirrored. Okay, so if it is a 2, I'm gonna return 5. If it is a 5, I'm gonna return 2. What else? And 6 and 9 are also like rotated, right? If a is equals to 6, return 9. And if a equals to 9, return 6. Else, we're gonna return -1, because this is just for invalid numbers. Now, for each of the numbers, so I equals to 1, I less than equals to n, I plus plus, we have to build a new number and check whether that new number is not equal to I or not, right? So for that, um, mm, 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 I can write temp maybe, something like, no, 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 not n, maybe a t, and then while, so this is, I'm basically extracting all the digits, or maybe I can just convert it into the string and then check, and that will be a little slower, but okay, no, let's do it this like this way only. So while t is not equals to 0, uh, okay. So what I'm doing here is I'm extracting 8 digits. So for example, let's say I have a number like 1, 2, 3. So I'm gonna extract 3, then I'm gonna extract 2, and then I'm gonna extract 1, right? And then for each of that number, I'm also gonna check for these, right? So if it is 2, then I'm gonna return 5. If it is a 6, I'm gonna return 9. And that number that's gonna be formed, we need to check whether that is equal to I or not. So it is a easy, I mean, problem, I can say that, but you have to write like lots of code for this one. Let's do that. I'm gonna get the remainder. So this is what we do in our childhood, right? This how you gonna basically what we say fragment the each digits in a number. So I'm getting the remainder, and then I'm saying um, maybe I can also say result, which is initially 0. And if, okay, int new r is equals to get r, and if nr equals to -1, I'm gonna break. Or maybe I can say like bad equals to true and then break. And here I'm gonna create a bad variable which is initially falsy, and after, and also we need a count in count to keep track of how many valid numbers we have seen so far. So if bad or result equals to I, um continue, else I'm gonna say count plus plus. And what else? Okay, now I also have to build this number, right? So after this loop, I'm gonna say result equals to result into nr plus uh, not nr, 10 plus nr. And I think this is it. So what I'm doing here in this part is, let's say I'm checking for a number 1, 2, 3, right? Whether that is a good number or not. 1, 2, 3. Okay. So I have to extract each digit 1 and then 2 and the 3, and then rotate them 180-degree and form a new number, and then I have to make sure that new number is not equals to I, right? So for example, let's say I have 1 to 3 I'm checking, right? So t is equals to 1 to 3. So I'm extracting this remainder 3, and so against 3 it will be 3 will be the bad, right? So it will fall basically. So let's say something different, maybe um 569. 569. This is the number we are currently checking, right? So I'm gonna extract 9. So result will be result into 10, which is 0, and plus 9. So 9. Then I'm gonna extract 6. Now 6 is 6 result, which is 9 into 10 in plus 6. So again 6, we're gonna return a 9, right? That's how we form a new number, and then we can check. But one problem is the number we are forming here is in the reverse order. So we also need to reverse the whole result here. So whatever result we get, we also need to make sure um, reverse of that result is correct. So how we gonna do that? Maybe I can write a reverse method. Um, Maybe I can extract this whole logic into a different method and then check maybe. But I think I can write quickly a one reverse method. So basically, I need to write a reverse. So whatever number I get, I need to reverse it. So if I get 1 to 3, I need to return like 3 to 1, right? So the easiest way will be to convert into a string and then reverse it. A more faster way in the logarithmic time you can do is using this logic, right? So we extract each digit and build the answer one by one. So something like this. While a is not equals to 0, um, I get a remainder which is a modulus 10, and I'm gonna say result equals to result into 10 plus r, and then a divided equals to 10. Okay, I forgot division here, right? The t divided equals to 10, and this is we are able to reverse, and then I'm gonna return the result. Now here I need to reverse also. So result is equals to reverse result, and then I'm gonna check whether they are equal or not. If they are equal, I'm not gonna be increase my counter. Otherwise, I will increase my counter and then return the count. I mean, so much code for such a small problem. I know, but there might be a easier way to do it. But uh, So complexity wise, it will be very fast. It will be like n log n, right? So for each number, we're gonna run these two while loop. And if you see here, we are dividing each t by 10, and even here also. So it is going to be very fast. So it will be logarithmic. So yeah. So this looks good. Let me run it. Whenever you write like this much code, there will be the chances that you will mess up something. And I think we have messed up something. I'm getting 5. But we should get like 4 only. So let's see for which numbers we are getting true, right? So maybe I can just write system.out.println I plus corresponding result that we are getting. Let's see. Okay, so for 2, 5, 6, 9, we are getting um correct. But for 10, 10 is not a good number. Why? Since they remain unchanged after rotating. So 1 is going to be 1, right? If I come here, so 1 is going to be 1, 0 is going to be a 0. Oh my god, this is so bad. Okay. Now you see here, this 10 is becoming 0, 1, right? And I'm again doing 0, 1 reverse. So that will be 1, not 1, 0. Okay. How can I handle that now? Hmm, I have to append that much 0. You see the problem here, right? What is happening? Let's say I'm checking for 10, right? So I come here. So instead of 5, 6, 9, I'm checking for 10. I hope my screen is visible. No? Yes. So if it is a 10, now using this loop, what will be my result will be? My result is coming like 0, 1, right? 0, 1. So this is technically 1, right? Now, this 1 and then I'm reversing 1, that will be 1. So 1 0 and against 1 0, I'm able to make a digit 1, and which is good, right? But 1 0 will be typecast to 1 0 only, and that's why it's breaking. Because we have this, what we say, 0 in the leading area, right? Whenever we are reversing it. So, how I can handle that? Okay. So for these kind of number like 1 0 1 0 0, we gonna have some problem. Is it only going to break for like 1 0? I'm not sure. Um, Maybe for some cases I can convert this into a string and then check. No, no, no. How I'm gonna? I can just, I mean, the easiest way will be just convert the string and check, but that will be very efficient and I might get TLE also. Because 10 to the power 4 is 10 to the power 4 is like 4 digits. Yeah, I think that is the only idea I'm able to think right now. So instead of doing all these long thing, let me write. So instead of extracting the digit and reversing, I'm gonna just convert that number into the string, reverse it, and then check. And I think that should be faster. Because we're gonna only going to have like 10 to the power 4, right? So that will be maximum like let's say 5 digits. And 5 digit is not that long. So I'm gonna comment out this method. This one I need it, and I'm gonna remove also these ones also. Okay, maybe I can just remove it. So same idea. So instead of extracting the digits, I'm gonna convert this into a string, something like this, like str equals to I plus this, right? and then I'm gonna iterate over each of these character, or I can just build a string builder sp new string builder, and I'm gonna iterate over each of the characters. I less than str dot length I plus plus, and I'm gonna get a corresponding um value against it. So char ch equals to str dot char at I, and not I have to some other variable like j maybe. So j and j here also, and then I'm gonna say int result, or maybe I can just change this method from int to char, and then I can to add a quotes. I mean, so no, I cannot do that. Okay, let me write something like this just to save some time. 8, and this one I will return like 5. This gonna return like this 2, 9, 6, and this one also, 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 this one also. And otherwise, we're gonna return a empty character. And then I'm gonna say char new ch is equals to get ch, and if nch, okay, if nch equals to this, I'm gonna say like break, or maybe bad equals to true, and then break. I also need to create a bad variable, boolean bad false. So this means that we found a digit that lies between this condition, right? So it will be invalid. So there is no meaning of checking for other characters. We can simply break out and check our counter, right? So now after doing this, I can just say sb dot append nch, and then I can just check if not sb dot toString dot equals str, then only count plus plus. Um, not bad and. Now our code become much simpler just because of this using a string instead of int value. And I think this is it for this part then. I'm going over each of the number in the range, converting it to the string, getting the corresponding character against it, making a new number, and then checking. Let's see. Okay, okay, here I have to change return type also, right? That's why it was failing. Okay, I'm getting 4 now, and that's good. Let's try submitting. I'm tired actually. Okay, we are able to submit, and you know the issue, right? So in the case of 1 0, when I was reversing, it was becoming 0 1, which I don't want. So that's why I converted that 1 0 instead of number, convert that into the string. So 1 0 as a string, and then reverse it. So that will be 0 1, right? So we will not lose our 0, and that's why it took that much long, nearly half an hour for us, and that's bad, very bad. But yeah, at least you learn something, I learned something, right? So otherwise, it's not. I think it will be the easy. If it is easy, na, that will make me sad actually. But yeah, let's move to the second question. Hopefully, this one will be easier. Okay, let's see. Questions is thought that's good. So you are given an array representing a row of seats where seat I is equals to 1 represent a person sitting in the ith seat, and seat I equals to 0 represent that ith seat is empty. Now there is at least one empty seat and at least one person sitting. Okay. Alex want to sit in the seat such that the distance between him and the closest person to him is maximized. Return the maximum distance to the closest person. It seems easy actually. At least we are able to understand the question in a one go. But here in this question, it is so. I mean, what do you mean by 180 degree rotation of a digit? It just doesn't make sense. But for this one, at least I'm reading just for the one time and I'm able to understand the question. So it says like there are seats, right? And there might be some person is sitting, right? And at least one person will always sit. Now there is an Alex. What he need to sit at somewhere such that the distance between any person sitting either in the left or in the right gets maximized. Now, if you see here, if the Alex sits here, right, at the one, it cannot sit at zero because already someone is sitting. So it can sit at this one at position, right? So what will the maximum distance? So here it is like zero distance, right? So it is like one, only one unit of distance. Here it is like one, two, three. So what will be the answer? One, because one will be the minimum, right? So we have to take always the minimum. Now, if Alex choose to sit here, right? So what is the longest in the right side? So that will be two. What is the longest in the left side? That is also two. So two. So for this position, what is the max he can sit, right? And what is the left? So I mean, okay, and it says like the constraint says like 2 and to 10 to the power 4. Okay, so I mean, you see, I have to sit somewhere and then I have to check in the left and I have to check in the right. So the very brute force you can do is make Alex sit one seat at a time. So let's say let's make Alex to sit on seat number 3, and just from the fourth index check what is the person, what is the very next person, and then also check just before that seat and the previous, like from 0 to that position -1, and from position +1 to the end of the array, and then keep checking whether what is the maximum distance. So for such kind of problem, I think we have something called prefix kind of thing. It's not technically prefix, but I think this I have seen some problems related to something like this where we have to check something in the right, something in the left. And if you have even it, I think it can be solved using monotonic stack also. But the problem with the monotonic stack is we still have to create like two sides, so that will be overkill, I think. So this is also not very tough. So how you can approach this one is something like this. Let me show you. Um, okay. So for now, just let's focus on the right side. So if Alex is sitting here at 1th index, just focus what is the closest right one, just in the right. We will take care of the left and later, right? So that will be the distance of 1, 2 unit. So if we can create an array to represent like what is the closest person sitting in the right side only. So for zeroth, he cannot sit right, of course, because that will be the zero. And for this zero, what is the closest in the right? So that will be 1, 2, and 3 units, right? Now for this zero, what is the right? So 1, 2. So there is two at position a person is sitting, so 2. For this position, what is the answer? That will be 1. For this position, he cannot sit, right? So I can write 0, maybe I can write a 0. And then for this position, what is the closest one? So that will be in the right side only, 1. And for 1, he cannot sit. So this is the array we have formed if we are taking only the consideration of the right neighbors. And similarly, we can do for the left neighbors also, right? So for this one, we cannot sit, so that will be 0. So that will be 0. Now, and again, for this, oh, sorry, this is 1. And for this position 0, we have to check just in the left. What is the closest one is there? So that is 1 unit, right? So that will be 1. Similarly, for this, what is the closest in the left? 2 units, right? So 2. For this, what is the closest? 3 units, right? So 3. For this, we cannot sit, right? So that will be 0. And for this 0, what is closest one? This one, right? That is 1 unit apart. So 1. For this, we cannot set, right? So that will be the 0. Now, if you see closely, we just have, okay, okay, I messed up. 1, 2, 3, 4, 1, 2, 3, 4, and this will be 0, this will be 1, this will be 0. So, now, so this is represent the very right side, the closest right side neighbor. This represent the closest left side neighbor. And if you see carefully, the answer is nothing but the minimum of these two. So for if I Alex it at second position, so that will take the minimum of these two. So 2 and 2 minimum is 2. If Alex sits here at the 1th position, the minimum is 1, and that's of course 1 unit will be the maximum distance Alex can maintain. So we have to build these two array and just take the minimum of these two. And this is very useful technique in multiple problems. You will say it's kind of like DP because we are storing, caching the results, right? And then we are checking, but it's not technically DP, but kind of very similar. So let's write the code for this also. We're gonna create a dot length, and then we're gonna create maybe int left, not very left and right. Left is gonna be new new int of length, and right is also new int of n. And let's first fill up the right part, right? So for that, I'm gonna run a loop from right side because that will be easier to calculate. Why? Because if you see, and this is also good observation. If you try to check who is sitting in the right side, so it's always a good idea to start from the end. Why? Because from 0 you have to check till this part, and you don't have result for the very next values, right? So we don't have result for 1, 2, 3. So, but if you set from 6, we can simply check whether the next seat is occupied or not, and based on that, we can basically find out. So let me show you how why I'm saying this. Um, uh, in the right, I greater than 0, I minus minus, and if I equals to n minus 1. Now here also one thing. So you see here the LX. So for the last state, it's a good idea to initialize the value with the integer that max value or something number that is always very large, because someone is not sitting in the right side, so we don't have to take that into the consideration. So we just need to focus on the left part, right? So that's why if I is equals to, I'm gonna just say right of I equals to integer that max value. Again, why this is so? Because we don't care about whoever sitting right. Because if the rightest element, there will be no right, right? So the answer wholly depend on the left part. Else, now here is the things getting interested. But, um, no, I think 0 will work actually. So maybe I just need to initialize from I minus 2 here. I think 0 will work because we are taking the minimum. We have to maximize the answer. Okay, we will see is it working or not, but yeah, we will start from if a of I equals to 0, then only of course we are able to set right. So a what we say right of I equals to a of I not a of I, right of I plus 1 plus 1. And why this will work is, let's say here, let's say we are calculating in the right side for this 2. Now we already have calculated the value for 3, and that is 1 unit, right? So what will be the answer for this? Whatever distance you have plus 1. Is it making sense? So for example, let's say for this 6, it will be 0. Now for this, whatever, since it is 0, whatever distance to the very next neighbor plus 1. So that will be 0 plus 1, 1. For this, we cannot say it. And for this, 1. For this, 1, 2. For this, 3, right? And then we similarly, we're gonna fill left part also. So for int I is equals to 1, I less than n, I plus plus, I'm gonna say if a of I equals to 0, left of I equals left of I minus 1 plus 1. And then I'm gonna iterate. I'm gonna have an answer, which is, let's say, we have to maximize it, so minus 1 maybe. And for int I equals to 0, I plus plus, answer is equals to math dot max of answer, comma, math dot min of left I and right I. And then we're gonna return answer. Okay, I will explain this one more time, so don't worry about it. Let's see first what if I'm getting the exact answer or not. So yeah, that's good. Let's see. Okay, we messed up. Yeah, so this was actually what I was talking about. So you see here now why it's failing, because for this state, right, the rightmost state, the left is like 3, but the right is 0, right? And that's why it is coming as like this. So um so what should be the idea? Idea is here we are initializing. So we have to say something like right of n minus 1 equals to integer that max value, and here also left of 0 equals to integer that max value. Uh, but just one issue here. Now, if you see, if AI equals to 0, I'm checking for the very left part, and if it is a max value, I'm doing plus 1, that will go out of bound. So I need to handle that also. Um, so for this zeroth part, so that will be integer that max, and that's fine. Uh, and for this 0, whatever distance you have, okay, okay, maybe we can handle that here only. Can we handle that? Left part, right part. No, no, no. We cannot do that. Maybe I can just write something like this. If left of I minus 1 equals to integer that max value, then left of I equals to 1, else. Similarly here also, if, because I don't want to make this out of bound, right? And here also, not here. Um, here, if right of I plus 1 equals to integer that max value, then right of I equals to 1, otherwise 2 plus 1. So for this case, if I'm at 0, so I'm right for the right of I, it will be integer that max value here, right? Now for this 0, ideally it should be 1, right? So there is a 1 state in the right side. But since we have integer that max value at the very right, at the very extreme, I'm just making that right is equals to 1. And that's fine too. So let me copy this array and check whether I'm getting now 3 or not. I should get 3. Yeah, now it's working. So let's submit it. Okay. Yeah, we are able to submit. So yeah, I hope you like it. I think and the both question I stuck, it is bad. Oh, actually, both were medium questions, so that is good part. Actually, if it was a easy, then I might have discussed it with myself. But I thought this one was easy, but it is also a medium, so that's fine. 20 minutes for a medium for someone like me, average programmer, that's fine. I will take that. So yeah, but the score was pretty low just because we messed up so many conditions. And for here also, I think it was very clear. It is not very fancy. So I think you should know this technique, how to check whether the rightmost element or the leftmost element in the linear time, right? So here it is the linear solution. So for this part, Alex, I'm just tracking what is the rightmost element, what is the leftmost element, and what will be my answer, the minimum of that two. So yeah, and for this one, I think this one was a little implementation kind. It's not very huge. It's not involve lots of data structure and algorithm. It's just an implementation based problem. We initially try to use this digit based reversal, but in case of let's say 100, we were getting messed up because this was converted into something like 0001, and that is technically 1, and that's why we are not getting the answer that we are expecting. So that's why I changed that number to a string and then reverse it and check it, and then it become very clear. But still, the question uh, ask is very weird. It's very hard to understand what exactly it's saying. But yeah, we were able to solve. So I hope you like it. Um, let's catch up in the next one. Thank you so much for watching.